I've come along from Swansea University. This work was done with my two supervisors, Matt and Mike. So the last time you watched television was likely that you were not just watching television. So we tend to do other things while we watch television, and essentially we're TV multitaskers. We tend to speak to people, tend to watch, drink, eat, and play with mobile devices. So there's been sort of studies in the early 2000s in various psychology-type journals that look at multitasking while watching TV, but this was before this digital device type thing became ubiquitous in our living rooms. So currently, Accenture puts the estimated sort of usage at about 87% of all people actually second screen. So television isn't this big, all-consuming thing that we've previously thought it may have been that sucks our attention in. And so the modern living room is a mixture of related, unrelated browsing. It's kind of, it gives us something to do while we watch television, effectively. So there's this lull in attention, and it's generally filled by things like social interaction. So this can either be tweeting about a thing. So these are two related examples. So you can either be tweeting about a debate or something like that, or tweeting to a television program. And so these run on the screen. And obviously things like query, like searching an actor that we recognize in a TV show. So broadcasters sort of cottoned onto this, and they've sort of started designing around this scenario and providing content related to the show. So BBC calls it companion content. I've heard various other things it's being called. So this, for a BBC example, tangential related information. So this is Autumn Watch application that runs alongside the show Autumn Watch. It sort of gives you fun information. These are facts about fish. And also, people started integrating social media feeds into applications. So this is an EPG type thing with a social media aspect to it. So so Kai and TVX sort of communities have picked up on this, and they've studied these as deployments, so people deploying a thing they've built, and also prototype systems, so more perhaps left field systems that we envision would be nice in future to have, and we've run sort of empirical studies with them. And then obviously there's a lot of eye tracking around this sort of area at the moment, because it's a split attention issue. So previously, last year in Kai, we presented this paper, and it was all about how we can move attention around devices. So different types of notification, how you can integrate them into a show. So things that likely affect attention. So you've got things like wind down TV and active TV. So these are more sort of like genre based, sort of mood matching type things. So we may wind down to something less, perhaps cognitively involving. And so also this scenario is massively affected by ergonomic factors. So the fact that the device is in our laps, so I have this chap here, and he's essentially having to look down into his lap and then raise his vision. And it's kind of a physical sort of disjunct between the two displays. And then the thing that we look at in this paper is actually dual screen complexity. So the complexity of the TV, so the perceived complexity, plus the tablet complexity, and how you can simultaneously take in these streams of information. So you have your audio, visual, TV stuff, and your tablet, which is typically visual, sometimes some additional audio. So questions, what makes for complex TV? That's a really ridiculously complicated question. What makes for second screen material to be complex, and how can we design to counter both of these things? We've split this into two studies. So we did a control study initially to just find out what's complicated TV, what's complicated companion content, and we varied graphical and textual complexity around standard metrics in the literature. So we measured things like glance duration, glance frequency, and general observations in the video, and then we looked at some Likert scale questionnaires, and we had an interview at the end. So we varied the complexity across for each participant. So participant 1 gets simple text, simple graphics. Participant 2 gets complex text, simple graphics, and again, complex graphics, text, and these go through the participants. So as the television show runs along, it's a show called Eggheads. It's a British show. Basically, while this quiz is going on, they're receiving this information. So participant 1 would receive this type of very basic information, and then obviously participant 2 would receive this sort of information. So we were able to counterbalance ordering effects and things like that. So we analysed the questionnaires, the interviews, and the video analysis. A lot of video analysis, and we ended up with sort of glance data initially, and so obviously textual complexity significantly affected the engagement with a tablet. That's quite an obvious finding. It's because we have to read we don't get a gist of textual complexity. We either have to investigate it line by line, or we have to speed read it or similar. And obviously you're going to get a larger standard deviation in the glances from that. So in the questionnaires, which I think were more useful, the textual complexity was a major impactor for taking stuff in on a tablet, and people often felt that they were missing stuff on the tablet because of the textual complexity, i.e. they were trying to focus on both the television and the tablet. And we did some general rated out of 10 type complexity ratings, and yet again the textual complexity was the main factor. So textual complexity was the big thing. The graphical complexity had a slightly smaller effect. So this is because there's, obviously, when we take in auditory information and textual information, they're quite hard to process at the same time. But also we found that it was driven by quite nuanced things. So, for example, if a participant knew that a snooker player was particularly good, or he would time his viewing based on this. There's a lot more of that in the paper, but it's best not to get into details like that now. So we wanted to see if we could pick out the 3 most common occurring things from the interviews and see if we could use them to actually drive the content on the tablet and for it to adapt its complexity. So we picked out intense dialogue, novelty, i.e. new things occurring, and semantically vital information. So intense dialogue may be a lecture somebody's giving, like this actually, where you have to actually listen to every single line, otherwise you'll miss something, and that relates to semantically vital visual information. So if something happens that you cannot necessarily pick up on from the audio feed, for example, if somebody draws a picture or something like that, and again, novelty, scene switches. So can we use these heuristics for the complex TV to balance the second screen content to make it simpler and more complex at certain points, was what we wanted to find out. So obviously too much information, too little information, and the literature seems to suggest that when there's not enough information on the tablet, the TV tends to dominate. So how do we design for this ideal sort of just right scenario, or at least aim towards it? So we design for the dual screen complexity. So we essentially just adjusted the complexity of the text. So we had set from the previous experiment 3 levels of textual complexity, and we looked at whether we could actually drive these with our heuristics. So if you look at A, you have T1, T2, T3, T4, T5. So we split them up into little time chunks, and then we, using the heuristics that I mentioned before, i.e. the dialogue happening, complex information, and semantically vital information, we essentially measured, we curated the content as maybe a producer would in a TV studio for the complexity, and we said, okay, this is complexity level 3, for example, and then we said this is a low-level complexity and a medium-level complexity. And then to compensate for this, we simply just inverted the value. So 3 becomes 1, 2 becomes 2, and 1 becomes 3. And then we also explored the concept of sort of the more info type thing that we see in websites more commonly. So you get a gist overview of the content, and then you allow the participant to actually, or the user, to adjust it themselves. So we did a controlled study to explore the second screen complexity adjustment. So can we adapt complexity on a mobile device to sort of beat the television complexity? So the study, the real things we wanted to find out was, do they notice? So if we give some content which is actually randomly updating, so every time they move to a new page, the content randomly updates, and we compare it to, say, this heuristic-driven curation where we've drawn the graph of the complexity inverted from the TV, and then we also compared user-driven. So we allowed the participants to adapt the complexity in a different condition. So again, we evaluated this using questionnaires, device logs, and interviews. So the general results were that the curated case worked. The participants were able to take in the screens better when they were curated to some heuristics. So essentially when the content was ramped down in complexity, they were able to either focus, they were more likely to be able to distribute their attention nicely across the screens, at least that's what they reported. And they generally preferred curated over adaptable because of the fact that adaptable has some perceived interaction cost that they have to go through with a more info type button. So in general, the detail of the tablet content was enhancing their experience as a whole for curated. So this is quite strange because even though, so we made certain that we chose the clips so that the average complexity would be the same. So with random, your mean would be something to tend towards 2. So if you have like 1, 3, 1, 3, 1, 2, 2, 2, whatever, it would tend towards 2. And then we did exactly the same with the curated content. So they actually seemed to notice the fact that when the content got simpler, so when something complicated was happening on the television, this actually seemed to improve their experience, and obviously compared to the random baseline that we had. So we used about 20 participants for this experiment. So also curated case strongly correlated with people who said that they were easily distracted by the devices, i.e. people who tend to constantly be on their phones while they're watching television, and they find it distracting because they can't take in the 2 streams. So device log data sort of suggested that people were more likely just to generally increase the content's complexity. And they tended to ramp up the complexity for uncomplex stuff. So if a piece of content was presented at the lowest, if the television was currently at the lowest complexity as defined by our heuristics, they were more likely to ramp up the complexity, and inversely, if it was higher, they were more likely to ramp it down. So predominantly the participants' instant response was to ramp up the complexity, obviously searching for more information, and for more lean-back types of programming, for example, a show where you'd not necessarily have to concentrate very much on very specific details, they were more likely to just not interact very much. So if you look at clip 3, it's essentially a cooking program, they were less likely to interact. But when for a nature documentary type thing, actually it was a David Attenborough sort of geographical documentary, they're actually more likely to increase the complexity because they probably wanted to find out more information. But so participants appear to feel the effects of the curation, but none actually explicitly noticed. So they didn't say, oh yeah, I definitely noticed that in the interviews. They seemed to just, they marked obviously down in the post-study questionnaires. This seems to indicate that they noticed it, but they didn't explicitly notice. Only a third actually did. So with 2 minutes or so to go, some discussions, reflections. So firstly, strongly consider the effect of cross-device complexity for designing lots of these types of experiences. So if you're a broadcaster, this means actually thinking about sitting down with your program and thinking about what you're providing to the user at each specific program. And obviously, if you're an app developer or general practitioner, this also applies. Consider actually trialing the content before distribution. So if you develop an app, actually sit it down with some users and just sort of assess their impact with standard workload metrics and things like that. And yeah, so you can consider curating the content in-house if you're a broadcaster, if you have this kind of budget for bespoke experiences. And also, you can also consider doing a mixture of both, although we've not studied that in the slightest, but actually consider adapting the complexity and then allowing them to dig deeper for more information with the more info buttons. So with this connected multi-device living room that we were beginning to have, essentially I think we should design for intra-device attention. So like I mentioned, the broadcaster designed experiences, you could actually have a producer sit down with the content providers and come together and actually think about how you could design an experience. So again, like summaries, so for example, Wikipedia, if you're pulling information off the web, obviously you can have simplified versions of certain data. And then obviously optimizing social media. So an obvious thing would be maybe in a live debate to only pull the most absolutely pertinent bits of information. Again, it would essentially not involve sort of textual processing, but it would involve only pulling the most, say, liked things or the most starred things, retweeted things. So that's about it. Thanks for listening. Questions? Here are the references, if they're all actually in the paper, so if there's anything in there you're interested in. And then finally, some contact stuff. Obviously, the paper's there and exists. Okay.
So I really like the focus on the tablet displays. I was wondering what advice you would have for television producers, given that they know what's happening offline with these tablets and phones. What advice would you have to give them, and how might you design a study? Well, that's a longer question. Let's do the first part. Just some simple heuristics for them.
I actually am co-supervised by somebody in the BBC who has just left. Oh no, he's not left, he's there. And so we've discussed this sort of stuff with actual content producers and the sort of people. I've discussed this with people who actually produce these sports run-along programs. So say, for example, if you're watching your football team play or whatever, you're into getting live scores and things like that. And I've discussed these ideas with them. And generally, they were quite interested. But I mean, I think the heuristics that we'd have to come up with would be just to cover all bases would just be incredibly complicated. So I think it will differ between each, obviously, program, because television shows are quite complicated. This was more of a proof of concept. We just had these three heuristics that were really common in our data, and we wanted to see whether it was a viable concept. It appears to be quite viable, the general sort of the gist of it is that I think more work's needed on the heuristics. Yeah.
Right, thank you. So our 20 minutes are up. Sure. So we're going to move on to the next paper.